Bohr model of hydrogen atom. Before Bohr, Rutherford also gave the different model of the hydrogen, right? So, and before Rutherford, Thomson was the scientist. He gave the Thomson model of atom. So from Thomson, finally to the Bohr, because there were some drawbacks of Thomson model of atom, Rutherford model of atom, and Rutherford model of atom, that was a very successful model, and from that model we came to know that the central part of every atom is positive, and that later on it was given the name nucleus. And in the Bohr model of a hydrogen atom, he used the simplest model, like it's a proton-electron system, right? Hydrogen atom is a proton-electron system, and proton is in the nucleus. There is no neutron in the hydrogen atom, and electrons, they are revolving, right? So, how we are shifting from classical physics to the quantum physics? When Bohr observed the spectra of the hydrogen gas, he took a glass tube and he put some hydrogen gas, he heat up the hydrogen gas, and finally when he observed the hydrogen spectra, then he find some energy lines, 656 nanometer, 686 nanometer, 486 nanometer, 434 and 410. These are the wavelengths which are emitted when the electrons of the hydrogen atom, they comes down to the ground state. So now the classical physics says that the emission of energy, that is a continuous process. But in the hydrogen atom, we are getting only the discrete spectra, only discrete energy levels, and discrete wavelength and discrete frequency. So this is a contradiction to the classical physics. So classical physics is wrong here, because in the hydrogen atom spectra, emission is not a continuous spectra, it's a discrete spectra. So to understand this discreteness in the hydrogen spectra, we have to understand, we have to do something with the classical physics. We have to do some changes in the classical physics. We have to adopt the new concept, that is a quantum concept, right? So these discrete energy levels, basically they are the part of quantum physics, because the quantum physics, they say that the absorption of energy by any object and the emission of energy by any object, that is a discrete process. Means energy can be absorbed or emitted by any object in a discrete way. Okay, so this is the simplest model, having the one proton and one electron system, right? So how he make this model? So many assumptions are there, right? So many assumptions. The Bohr took so many assumptions. So the first assumption: imagine the electron that is not in the circle. It is at a certain distance from the proton, where the electrostatic forces are not there, right? So now if you see this electron which is away, far away from the electrostatic influence of the proton, so here the frequency of the electron, that will be 0, right? Frequency means it's not doing any rotation, right? Frequency is 0. When frequency is 0, so you will see the energy, that is also 0. But the moment this electron that comes out and start moving in this circle, when this comes here and then it start moving, right? It start moving. So the frequency, it attains some frequency and it attains some energy, right? So the frequency it attains and the energy, so the energy that shifts from 0 to some value, so definitely this will be the negative energy. Okay, it is shifting from, so means when already the energy is 0 in something, right? And it start doing some activity, like activity means it start doing a rotation, okay, in a fixed orbit and with certain frequency. So frequency is the activity now the electron is doing. So with no energy, it start doing some activity. It means it has a negative energy. With no energy, it start doing activity. The activity is the frequency, right? Activity is a rotation. Okay, in a second, how many round it takes, right? When the electron is here at a radius r, now what is the energy right now within the electron? What is the energy? Or we can say, what is the energy of this hydrogen atom now? Okay, energy of the electron or energy of the hydrogen atom. Okay, so now if we calculate the energy, so that will be equal to the total energy I am calling, so that should be equal to the kinetic energy of the electron plus potential energy of the electron. Okay, and the potential energy, that is negative energy, so I will take negative sign. So this energy that can be written as kinetic energy, we know half mv square. V is the linear speed, okay, m is the mass of the electron, minus what is the potential energy of the electron. Potential energy that can be written as E square. E square means this is E and this is also E. This is plus E, this is minus E. Okay, so I can write E square divided by 4 pi epsilon naught and the distance r between them. Okay, so I will write this distance r in a different color so that we can understand what is the importance of r. R is important for us. Okay, so energy is equal to kinetic energy minus potential energy. Half mv square minus, this is potential energy. This is plus E, this is minus E, so according to the Coulomb law, so this will become E square. Okay, 4 pi epsilon naught, this is a constant, and R, right? So with this energy, so let me write in a box. This is the total energy, right? So we will say this is the total energy of the electron. Energy of, this is energy of electron, or you can say energy of electron proton system, or you can say this is the energy of hydrogen atom. Okay, so I'm writing this is the energy of electron. Okay, energy of electron. Now the second part we will consider, there is some force also, right? We will take the classical concept that if some activity is done, definitely the force must be there. If some activity is there, some rotation is there, definitely there is a force behind that, right? So now again we will use the classical concept of force, right? And you know that it is moving in a circular motion, so there is a centripetal force. Okay, and that centripetal force that must equal to the electrostatic force also, right? The same concept we use in the gravitation, the centripetal force, right, that is balanced. So the same concept we will use. So the force on the electron, right, that is equal to mv square upon r. R is the radius, v is the linear speed. Okay, and this should equal to electrostatic force. So electrostatic force, that is force between the proton and the electron. So E into E square, again the 4 pi epsilon naught. Now the force is inversely proportional to r square. This is the potential. Potential is inversely proportional to r, but the force is inversely proportional to r square. Okay, so again I will highlight this r square. Okay, so difference between the potential is inversely proportional to r, but force is inversely proportional to r square, right? Now if we consider this equation, now you see we have E square 4 pi epsilon naught r, and this is E square 4 pi epsilon naught. Now this r cancelled. Okay, this r cancelled. Now I can replace E square upon 4 pi epsilon naught into r by this equation. Means now I can place mv square over here. Okay, because E square upon 4 pi epsilon naught, E square upon 4 pi epsilon naught into r, that can be replaced by mv square. Okay, so if I substitute this value, means this can be replaced by mv square. Clear? Simple mathematics. So now I replace mv square by this. So now what is my final energy? So the final energy, that will be E equal to half mv square minus mv square. So this will be E equal minus half mv square. Okay, half mv square, right? Okay, E is equal to minus half mv square. So first I use the concept kinetic energy minus potential energy, and then there is a force on the electron-proton system, and this is the centripetal force because it is moving in a circle, centripetal force, and this is the electrostatic force between a positive and a negative, right? And finally, I get E is equal to minus half mv square. Okay, and this electron is doing angular motion. It is doing a circular motion. So we know that V is equal to omega into R, right? V is equal to omega into R. So now what I'm doing, I'm trying the frequency part, right? Because I have to solve the energy and frequency together. Okay, energy, total energy of the electron and the frequency also. So now by using this equation, right, V is equal to omega into R, where V is the linear speed, omega is the angular speed, right? And omega can be written as 2 pi into frequency into R. When I take frequency, means I will make a small round here, okay? Because this is velocity or the speed, and this is the frequency, right? So this is another equation, relation between the linear speed and the frequency. From here I can calculate the frequency, right? So from here if I calculate the frequency, so the frequency nu, that will be equal to V upon 2 pi R, 2 pi into R. Okay? So now we have the frequency. Now one more concept about the frequency. If we see this diagram, here the frequency is 0, and finally when the electron that enter in this circle, the frequency becomes, means now the 0 frequency that turns a certain frequency. Okay, and energy is changing from 0 to negative. So now what is happening when frequency changes from certain value 0 to some non-zero frequency? So energy also changes from 0 value to some negative value. This is an important point. When something, how the Bohr make a mathematics, how the scientists they create the mathematics, how they try to explain the physical world in mathematical form, right? This is a model, mathematical model, right? Which mathematics, so this paper, this is a research paper published in 1913. Okay, so this was the total mathematics. Now when the frequency changes from 0 to some value of frequency, because now it's making it round, okay? So energy changes from 0 to some negative value. Now Bohr assumed one more concept about this negative energy, right? Now this negative energy, one assumption, already we know this is the energy, right? There is one more concept, or the one more format of energy, used by the Bohr, okay? And this concept about the energy, this negative energy of the hydrogen atom, actually that is H times nu, okay? That is equal to H times nu, nu is the frequency. But he take this as integral multiple of n. Integral multiple of n. The energy, this negative energy, this will be integral multiple of n, where n is integer, right? 1, 2, 3. It cannot be 0. Why it cannot be 0? If we say it is 0, it means now it's not moving in a circle. Okay? If we say it is 0, so it means it is here. Okay? But when we use some integer and we get the negative energy, it means it is in a particular circle. Okay? One more thing, it starts from 0 and then attain some value of frequency. So if we take the average value frequency, so I will divide by 2. This is assumption, okay? This is assumption of Bohr, right? Mathematicians, they assume few things, okay? So this is assumption. assumption. So now you have two types of energy. This is the equation for energy, and this is also the equation of energy. Okay, and this is the assumptions of energy, right? So now if we substitute this frequency here, right? So what we will get? Now we substitute the frequency, so we will get minus E, that will be equal to N H is a Planck constant, and first I write by 2, and then this is V, speed, divided by 2 pi into R, right? So let me give these names: equation 1, equation 2, equation 3 or 4, right? So this is my first equation, this is my first equation, okay, first equation, and this is my second equation, third equation, and finally minus E, that is my fourth equation. Okay, so this is my fourth equation. Now everything we have to do with these four equations. Now these four equations, now we will start our journey, we will start our mathematics from these four equations, right? So in these four equations we have radius, okay, we have radius, R here in equation 4, R here in equation 3, okay, and R here in equation 1 also, okay, and in equation 4 we have speed, okay, and in equation 2 also we have speed. Now we have to do some elimination, right? Elimination, like if I take equation 3 and 4, okay, means 2 pi R. Okay, if I say this is 1, this is 2, or we can say this also 3 or this, no problem, right? So first I will eliminate something, and I will eliminate R, right? So where is the R? We have R in two equations, okay? So this R here in this equation, and R here in this equation, okay? So first I will eliminate R from equation 1 and 4. So eliminating R from equation 1 and 4. Equation 1 and 4. So let us eliminate from equation 1. So I can write 1 upon R, okay, 1 upon R. This is 1 upon R. So 1 upon R, that can be written as, this will be equal to, keep in mind the positive and negative also, right? This can be written as mv square into 4 pi epsilon naught divided by E square, okay, right? If I eliminate R from equation 1, then I will get this. Now eliminate R from equation 4, this 1 by R, so that I can compare the new equations, okay? So this is 1 by R. So 1 by R, now that will be equal to, okay? So this can be written as minus E, right, 4 pi divided by N, H and V. Okay, so 1 by R, that will be equal to 4E pi, 4E pi or 4 pi E divided by NHV, right? So call this as equation number 5 and this as equation number 6. Now we can compare equation 5 and 6. Okay, left hand side is equal, so I can equate the right hand side. So now equating the right hand side, so what I will get, 4 mv square into 4 pi epsilon naught divided by E square is equal to this minus sign, E into 4 pi divided by NH into V. So check if anything cancel. We can cancel 4 pi, 4 pi, 4 pi cancelled. Okay. Now I will calculate V, this V, speed. So you see, this is V square and this is V. So if we cross multiply, that becomes v cube. I will calculate this speed of the electron moving in the orbit. Okay, so this is, now if we cross multiply, okay, if we cross multiply, then what I will get? I will get v cube. Okay, check if any other thing that can be cancelled. No. So v cube m epsilon naught n into h, that will be equal to minus e square into e. Calculate for v, so this becomes v cube. V cube is equal to minus e square e divided by m epsilon naught n into h. Okay, so if I shift this cube, that becomes cube root. Okay, so the cube root, and again because this is a cube, so again it will be negative, right? If it is a square, then this will become positive. But if it is this is a cube, so the final result, that will be minus minus plus, and then plus minus again minus. Okay, so this becomes equal to e square e divided by m epsilon naught n into h, and this is cube root 1 by 3. So this is the actual speed of the electron moving in this orbit. So we have the energy of the electron, we have the frequency of the electron, we have the speed, linear speed of the electron. Okay, right?
Yeah.
And this is negative, right? This is negative, so I will put a negative sign. This is negative, so this is negative. Okay, finally this comes out to be negative. So call this as equation number 7, right? Now if I substitute the value of speed in this equation number 2, because in the 2 we have half mv square, because energy can be defined as half mv square, right? Electron has a negative energy, and that negative energy is half mv square, right? Electron has a negative energy. It starts from 0, then it moves in a circle with this much of energy, and we know the speed of the electron. Okay, so this is v and this is v square. So when I put this value over here, so this will become positive, but finally this will be negative, because already we have a negative sign. Because if I do the square, this will become positive, because this is square, so this will become positive. Okay, when I substitute here, clear? But finally the energy will be negative. Okay, so now I am going to do that. So now substitute equation 7 in equation 2. Okay, so substituting equation 7 in equation 2. Okay, so in equation 2 we have E is equal to minus half m. Now this is v square. Okay, so if I take the square of this, so this will become plus, and I can write E square E by m epsilon naught n into h, and this will become 2 by 3. Okay, it is 1 by 3, but when I take this square, it will become 2 by 3. Okay, but now you see again we have a problem. We cannot do our mathematics if we have the two physical quantity in the left and right side. So in the left side we have energy, and in the right side I have energy. So what I will do, I will shift the energy from the right side into the left side, right? So this energy is e power 2 by 3, and this energy is e power 1. Okay, so now e power 1, this is e power 1, and when I shift e power 2 by 3 in the left side, so this becomes minus 2 by 3. Okay, and in the right side I have minus 1 by 2, or simply I can write m by 2, m by 2. Okay, and this is e square e m epsilon naught n into h. Okay, and this is 2 by 3. So this energy, this is 3 minus 2, 1 by 3. This is 1 by 3 is equal to minus m by 2 And same thing, E square E m epsilon naught n into h and 2 by 3. Now if I cube both sides, so cubing both sides, okay, cubing both sides, okay, so cubing both sides now, cubing both sides, or take cube both sides, cubing both sides. This is the way the scientists they solve the mathematics, right? So when I take cube both sides, so this will become e power 3 by 3, we are cubing both sides, equal to cube of this will become minus. Cube of minus, again we have to take cube of minus also. So cube of minus is again minus. Okay, and cube of m is m cube, and cube of 2 is 8. Okay, so cube of this becomes 3 by 3, and cube of minus is again minus. Cube of m is m cube, cube of 2 is 8, right? And if I take cube of this, so it means I am multiplying by 3. So, right, this will be cancelled. Right, this will be cancelled. So what I can write? I will write e power 4 e square divided by m square epsilon naught square n square h square, and this becomes only e. Right, e power 3 by 3, this becomes e. Now this is m cube, this is m square, so this m will be cancelled, so I can write e equal, right, this will be cancelled, so I can write e equal minus, this will only be m by 8, and this will be e power 4 e square, m is cancelled, epsilon naught square and square h square, right? So this is our final energy of the electron, final energy of the electron, right? Final. So when the electron moves from zero energy, it moves in some orbit, right? Like you see the Chandrayaan-3 launched by ISRO, that enter, right? So this was Earth. From Earth orbit, finally it moves in a trajectory, right, in a parabolic path to get into the trajectory of the moon. So when the Chandrayaan-3 that was inserted into the moon orbit, so then it start moving circular motion, it start doing circular motion, right? So when anything that enters into the gravitational or electric field of any object, so this is the field of this proton. So when this electron enter into the electric field of this proton, then they start doing rotational motion, right? And when it start doing rotational motions, then the energy of this electron or this system, frequency of this electron and this system, speed of this system, means speed of the electron, and finally the energy of the electron, that is given by this equation, right? Such a complex equation. Now if we put n equal to 1, n equal to 1, now so let me write this equation here. So E equal, this is a negative energy, right? So we can write m e power 4 e square. So why I am writing e? E should be E should already E is out, so E will not be here. This will be E naught will be here because I have taken the E outside. Okay, I have taken the E. So this E is not here. This E is not here. Okay, because already it is shifted in the left side. So I will not take this E. Clear? Because why I am using E again and again? Because already it is taken. Already it is taken. So only energy in the left side, not in the right side. No energy in the right side. So it is m e raised to the power 4, right? And this is 8 epsilon naught square n square h square. So this is the final energy of the hydrogen atom, right? And for n is equal to 1, because we are using n are integers 1, 2, 3 and so on. So for n equal 1, so E1, right? E1, that will be equal to minus, if you do the calculation, put the value of mass of the electron, charge of the electron, put the value of epsilon naught, put the value of Planck constant. So you will get minus 13.6 electron volt. This is the minimum energy of the electron in the hydrogen atom. Minimum energy, right? So this is the minimum energy of electron in hydrogen atom. Or you can say this is the ground state energy of the electron in the hydrogen atom, right? Or you can say this is the ground state energy. Because ground state energy, that is always the minimum energy. So this is ground state energy of the electron in the hydrogen atom, right? Now we are interested why, when we heat up the hydrogen gas, and why we are getting only these frequencies, only these wavelengths, why we are getting, right? So one more scientist, Bohr, the Balmer, all right, the Balmer. So one more scientist, Balmer, B-A-R-M-E-R, right? He again worked on the same formula and give Balmer formula, right? Balmer formula. So what is the Balmer formula? Balmer formula, that is about when some transition happens. So it's about transition from one state to another state, to another state. Okay, another state. So Balmer again assumed that if this is the ground state energy, right? If this is the ground state energy, so let me draw again here. If this is the ground state energy, okay, if this is the ground state energy minus 13.6. So if this is the ground state energy and I took E1, and this is minus 13.6 electron volt, right? Then how we can write the other energy states? The other energy states, they will be like this. Okay, so this will be E2, right? And E2, that can be calculated when I place n is equal to 2. Okay, for n is equal to 1, I get the ground state minus 13.6 electron volt. But when I substitute n is equal to 2, so this is n is equal to, when I put n is equal to 1, and this is when I put n is equal to 2. So when I put n is equal to 2, so finally we will get minus 3.4 electron volt, okay, minus 3.4 electron volt, right? And as we go, and finally we put n is equal to 3, so we get one more energy states for n is equal to 3. So for n is equal to 3, we will get E3, and this is for n is equal to 3, right? And we will get, after putting the value, minus 1.5 electron volt, minus 1.5 electron volt. And notice as we go up, the energy states, they comes together, they come close. Okay, now the fourth energy state, that will be closer. As we go up, the energy states, they become closer. So for n is equal to 4, this is E4, and the value of the energy, that is 0.85 electron volt, minus 0.85 electron volt, right? So after doing all the calculations, right, after putting the values, right, so we have these. Now using this formula, right, using this formula, E equal, so this is transition from one state, right? So now we are studying the transitions from one state, one energy state to another energy state to another energy state by using the Bohr formula. And Bohr formula for the energy, that is equal to me power 4. Okay, it's minus me power 4 divided by 8 epsilon naught square. Okay, and this is h square and this is n square. Okay, so when we check the transitions, so this formula will become 1 upon n final square, n initial square minus 1 upon n final square, right? So this is the final formula. Final energy state, transition means from higher to lower. Transition means from higher to lower, right? So why we are getting these wavelength in the hydrogen spectrum? This is a visible range, right? This is a visible spectra. This is a visible. We can see. That's why it's a visible spectra. Okay. The scientists, they observe. They find these colors. Okay. So this is a visible spectra. Then when they saw it, so visible spectra. And visible spectra is possible when the transition happens to second. Means this is the final, okay, and transition will happen from here to here, right? Means wave, some wave means transition happens from here to here, right? Means electron jump from 3 to 2. When electron jump from 3 to 2, then a wavelength will be produced, and the wavelength that will be 656 nanometer. Okay, when electron make a transition from n is equal to 3 to 2, so it will be 656 nanometer. Okay, so from 3 to 2. So final is, so the formula is, you can use this formula also, delta E is equal to final energy state minus initial energy states. Okay, final minus initial. So final is this, initial is this. Okay, so when you do all the calculations, so from 3 to 2 you get 656 nanometer. And when 4 to 2, when the transition is from energy state 4 to 2, right? So we get 486 nanometer. We get a wavelength 486 nanometer. Okay, and again we can take one more energy state. Now the energy states, they will be closer. Okay, so this is another energy state, and this is E5. Okay, this is E4 and this will be E5. Okay, now when the transition is from E5 to E2, right? 2 is the final. Now 434 nanometer will come. Okay, now 434 nanometer will come, right? So this is a visible. Infrared will also come, but we cannot see, right? We are observing only the visible spectra. So why in the hydrogen atom only these colors comes? Why not any other color? Why only these wavelengths? So these wavelengths are coming because the electron having this much of energy, right? They make a transition to the E2, right? E2 is the final state. So when they make a transition from E3 to E2, then 656 nanometer. From 4 to 2, 86 nanometer. 5 to 2, then 434 nanometer. And when 6 to, finally, if we take 6 also, this is for 6, and this is our 2. So this is E6. And when 6 to 2, then 410 nanometer. Okay, so the classical theory failed, and this become very famous. That's why it is in every book. In every book, every physics book, this model we are using, Bohr model, and how the transitions happens. Why experimentally we observe only these wavelengths that can be explained by this transition model, right? So transitions are to the second energy states from third, fourth, and fifth and sixth. Okay, so this is all about the discrete nature of emission of energy. Energy is emitted in a discrete way, no, not in a continuous way. So that's why the classical theory failed. Okay, thank you.